So when we say that we take a cognitive neuroscience approach to studying human behavior, what we typically mean is that we're interested in the relationship between brain and behavior. Now, there are at least two broad categories as to how we study this relationship. On the one hand, there are so-called manipulation approaches. And these are cases where we change the way in which the brain functions, and we try to see how this affects behavior. And this, for example, might be the case of when somebody suffers a lesion in some part of their brain. You might be able to observe some particular behavior results changed. And this, of course, tells you that that part of the brain is important for that behavior. Without needing lesions to occur naturally, in the laboratory, we can use techniques such as transcranial direct current stimulation or transcranial magnetic stimulation to put in brief and small electromagnetic stimulation in the brain and really affect the way it works, change the way it works. And what we can do is we can target certain parts of the brain, change them, and see how that affects somebody's behavior. Now, the other way around, we can use so-called measurement techniques. And these are techniques where we have somebody perform a behavior that we care about, a behavior that we want to study. And as our participants do that, we record their brain activity. And you can do this, for example, with electroencephalography. You can do this with positron emission tomography, which allows you to look at, while somebody is performing a task of interest, what parts of their brain have an increased metabolism. And of course, you can do something similar with what we are interested in for this class, which is functional magnetic resonance imaging. So MRI, and you can see here a sketch of a typical MRI machine, and we will go into some detail about how the parts of this machine allow us to study the brain. When discussing the brain, you can take several different types of images of the brain using MRI. For example, you might notice that at the very top, we can take images that are highly detailed and that show us very well in detail the anatomy of the brain. And these happen to be called the T1 weighted images. And we will discuss why they have this name. Other type of images are better suited, for example, to look at the blood vessels, these black lines that you see here, in what is known as a susceptibility weighted imaging. And these different type of pictures of the brain typically give us slightly different information. Now, with respect to fMRI, typically we care about so-called T1 weighted images and T2 weighted images, or T2 star weighted images. As I was saying, when we do an fMRI experiment, typically we take two types of images. On the one hand, we take what is known as a structural image, typically using a T1 weighted image, which is what you see here, which is one picture that shows in high resolution somebody's brain tissues. And you can use it, for example, to reconstruct the anatomy of the brain in 3 dimensions. The second type of image is typically known as a functional type image. And there are several types of taking functional images with MRI. However, we will be primarily concerned with so-called T2 star weighted images. And I will explain how exactly we obtain these images a little later. Now, see, the big difference between these two images is that the image on the right is a static image. It's one image in very high detail. The image on the left, it's a much grainier image. The reason is that we quickly take several pictures of the brain back to back, one after the other. And what we do is we look at how the signal of the brain changes together with somebody performing some kind of mental activity. You might imagine an experiment where you put somebody in an MRI machine and you have them listen to stories. And then other times they just listen to silence. And then they listen to stories again. And then they listen to silence. See, with dynamic images, what we want to do is we want to see whether any part of the brain becomes more active with some mental task of interest, for example, listening to stories, and then stops being as metabolic, as active when you're not listening to anything. So the two types of images, what we do with them is profoundly different. But we will discuss this, this type of dynamic imaging and analysis in greater detail later on. The end result of a typical fMRI experiment looks something like this. In gray, you can see the detailed anatomy of somebody's brain. And then what you see in these colors is the result of a statistical analysis that tells us that this part of the brain became systematically more active every time the person was engaging in some mental activity. For example, as I said, listening to stories. So the typical end product of an fMRI experiment is to localize on a highly detailed anatomical scan what parts of the brain seem to get more and less active together with some mental activity.